Many of you will be familiar with Whisper, a transcription model developed by OpenAI that you can use to convert audio into text. Now, Whisper will tend to transcribe English into American English. And so if you want to very cleanly transcribe into British English, or in fact, if you want to be closer to perfect with American English, that's something that can be a bit more difficult to do. I'm going to show you models that I have developed that do consistently transcribe into British variant or into the American variant. And I'm also going to show you some of the tools I used to train these models. The models are available in two variants, a tiny variant, which is very fast, and that is open source, and also a turbo variant, which is larger and more performant, that you can purchase. I'll put a link below to the models that are available. You can find them in this Hugging Face collection here. There are two data sets, small test data sets, to test out the transcription abilities, going to British English and also going to American English. And then there's a suite of models here. There's a model that goes to British English in the tiny variant, and then the turbo variant. There's the same for going to the US English variant, a tiny model and turbo. And you'd also see there are C Translate 2 variants of these models available. These are prepared so that you can run faster Whisper, which is interesting if you wish to run a server. And I'll put a link below in the description if you want to take a look at how to run Whisper models as a service by setting up an endpoint. Now, for background, if you just transcribe with Whisper, you will tend to get American English. And I want to say a few things here. Whisper will tend to look at the words that are within the audio and decide whether it should transcribe into British or American English. For example, if you use words that are very American, like garbage or rubbish, then the other words in the sentence will tend to be transcribed into American English. Likewise, if you use more British English words, for example, bin, then it's going to tend to transcribe into British English, which is good. And this makes sense because that's the kind of data it would have seen. If it ever sees the word trash, then it's likely also going to see words that have American variant spelling. However, if you have words or if you have audio where there are no words that clearly indicate if this is British or American English, then the model does not know and it will just tend to transcribe into American English. And so more or less, you will get American English from Whisper. However, in certain cases, you will get British English. So if you're transcribing to American English, Whisper is generally fairly accurate. If you're trying to transcribe to British English, then it will generally over-transcribe into American English. So I'm going to run some of these models here. Okay, so here I have the tiny model and I have the turbo model, and I'm going to compare the turbo model going to British English and going to US English. So I'll scroll down and grab the snippet of code. If you want to try this, just try it on the tiny model variant because that is publicly available. So I've copied this code snippet and I'm going to pull over now a terminal. So let's increase the screen size, paste this in. I'll increase everything here. And now I'm going to do the same and show you the American English version. So here I'll scroll down, grab this little snippet that will allow me to run inference. And I need to go back to my terminal, paste this in, and it should transcribe. And what this will do is download the model, download the data set, and it's going to run inference. And the data set here is specifically designed. It's a test data set that the model has not seen during fine tuning, because these are Whisper models I fine tuned using larger data sets, but the test data set has not been seen. And if you want to check out the test data set, you can take a look on Hugging Face. I'll put a link below. It's a set of data where I have sentences that contain words that have different spellings in British and English, in British and American spelling. And then I have created the data set such that here for transcribe to ENGB, the target language is always British English, and it's got British English spellings like recognizes, or here say defenseman, or here, what's the word? Vapor, spelt with O-U-R instead of O-R. So it will have many examples of British English listed here. And I'll talk a little bit later in the video about how exactly I prepare those. So going back to my terminal, we should be able to see now we've got a first reference of British English, and indeed it uses British English here. She recognizes. Here's the ground truth, British English. Here's another example, defenseman spelled with C because it's British English. And by contrast, if I go to the American English spelling, you can see here in the transcript, it's American English, recognize. And in this second example here, defenseman spelled with an S. So you can see how, depending on which model you choose, you can consistently transcribe into one language or the other. Now, I want to say a few things about how I evaluate the performance of these models. And that'll be helped just by scrolling down the model card to see the performance. And there are two ways I look at performance. The first is, how does it do at transcribing in the British variant or in the American variant? And then I just look at the general performance on a LibriSpeech dataset, which is a general audio text dataset. It doesn't have a very high incidence of words that have different spelling in British English or American, but allows me to just test the baseline word error rate to see if the model performance has degraded when I ran the fine-tuning. So to start, let's look at the performance transcribing to British English of this series of models. And you can see if you run a baseline model, OpenAI's Whisper Tiny model, it will tend to have about 6% of words in this curated data set that are actually in the US variant, whereas it will tend to have about 0.5% that are in the British variant. So it's telling you that as a baseline, the Whisper models tend to transcribe more into American English than British. And that's the same on Turbo. About 5% of the words in this curated test set are in American English, and about 1.5% are in British English. Meanwhile, if you then use the fine-tuned model, this flips because it's tuned specifically to generate British variant. And so now it kind of flips. About 5.5% are British English and 1% are US English. And then if you look at the fine-tuned Turbo model, it's got basically all of the words being transcribed into the British English variant. Now, if you go to American English, the difference is smaller here because the baseline models will already tend to transcribe into into American English. So 6% are American English already, or 5.5% for the Turbo model. And now if you look at the tuned model, it just cleans it up a bit more. So now you have 6.84% being transcribed to American English and very few words being transcribed into British English. Now, you might ask, how do I measure what percentage of words are being transcribed one way or the other? And the answer is, I've prepared a long list, which I'll show you, and I've open sourced. It's a list of about 6,000 different words that have different spellings in each variant. And I just do a find replace. So I check for all of the instances of that list of words in, say, the American variant or the British variant. And that allows me to measure what percentage are actually being generated in the US or the British variants. Now, the second thing I look at is whether fine-tuning the model degrades the performance. And for that, I just look at the word error rate on a standard data set, namely LibriSpeech. You can check out the data set here. It's not my data set, but it is open source. And the test split I look at is, I look at 50 rows from test other. Now, in LibriSpeech, you have some audio samples that are either clean, or you can also get some under the test other split, which is determined by the word error rate of transcription models. Test other is a higher word error rate, meaning it's a noisier data set. And this is the one I use to check that I haven't damaged the model too much during fine-tuning. So yeah, I take 50 rows of that, and I use that then to evaluate the effects on word error rate. And what you find is when you fine-tune a very small model, like the tiny model, you do have some degradation in the performance here. And maybe this could be improved if I included more general data splits into my pre-training mix. But what you can see is as you move up to a larger model, actually the word error rate does not suffer with the fine-tuning. And my word error rate is pretty similar here for the fine-tuned models at the Turbo scale compared to the original Turbo model here. So this shows you that it's possible to fine-tune a model to consistently output American English or British English, and the quality of the model is also quite good as well. So you can find a full list of the models. As I said, if you want to play around, you can play around with the tiny models. Note that the tiny model transcription accuracy, both for base Whisper and the fine-tuned variants, is quite a lot poorer than the turbo one. But if you're interested in the turbo one, that is available. It's gated. You can purchase it lifetime access to either the British or the American. Actually, it's just one purchase and you get access to both models, including as well the C Translate 2 version, which allows you to run a server. And I can I'll link you the video if you want to understand how to set up a server. So for more on the turbo models and the licensing terms there, you can head over and read through just at the bottom. There's a description on the licensing and usage for these models. Now I want to talk about how I train these models, and in particular I want to go over how I prepared the datasets. And I did this using a library I've developed and open sourced here called Whisper English Variant Converter. It's a deterministic library that allows you to swap from one English variant to another variant. And you can check it out yourself if you head over to this URL here. And essentially what it does is build a list of English spellings in British English and a list in American, and allows you to run swaps between the two. It also defines a set of exceptions that are skipped. So for example, sometimes it can be hard to just swap out a word. If you have the word check, well, the British spelling would be check with QUE, but check, of course, is another word, such as to check your homework. And so if you just swap it everywhere, that's going to cause issues. So what I do when I generate a lot of synthetic data, I have to generate synthetic voice data and synthetic transcripts, is that I'll generate text using an LLM. I'll generate it to contain these words that have different spellings in either language. And then I will deterministically replace the variants to be either British English or American English. And then as a further pass, I will use a language model to do any other conversions that have a bit more semantic dependence. So for example, in my deterministic swap, check would not get swapped, but it would then likely get swapped by the LLM pass, where I use a strong LLM to go back over the transcript and convert it to British English or American English. And then I can train on that data set of British English transcripts paired with voice. Now, if you want your model to be robust, you need to make sure that the voices are quite diverse across different variants of English themselves, so that you can consistently then get into British English or American English. So here, I'll just show you a few quick examples. I've cloned this repo, Trelis Research English Variant Converter. I've got it cloned here. And if you want to, for example, do some quick transcription followed by deterministic swaps, and you can just do this for free by using the base Whisper models. So here I've got some sound that I can play. Let me just see if I can play this here. It may be a bit unclear just because the way I have my microphone set up, but suffice to say, I have a UK accent here, and I have a US accent, a sample of data. And what I want to do is transcribe this, first using Whisper, and then using this repo to do the swaps. So for example, I can clone Whisper here, CD into that directory, build, and then I can transcribe the samples here. And once they're transcribed, let's actually, just as a demo, delete some of these files here. And let's clone Whisper, and we will transcribe here. So it's building Whisper right now using the Whisper CPP library. I'm on Mac here, but you can get it to work on other hardware as well. It's transcribing. So you can see here, it's transcribed out this text, my US accent recording. And notice how I've made these recordings to contain a lot of words that are different in British and American English. So you have realized, favorite, and then here UK accent and UK English. You've got favorite spelt O-U-R. So with those transcripts, I can then pass those transcripts into my deterministic converter. And the ones I'm going to convert in, I'm going to convert the US accent, US English into British English. So I'll just run this here. And you can see it's now converted it. So this should be in British English. And indeed it is. Favorite, realized, And you've also got some stats because I passed in the stats flag here when I ran this. You can see the swaps. So we've got center to center, check, cozy. And here at the moment, I have allowed this check swap. But if you wanted, you can go into the data and you can list in the exceptions file here anything that you might want to skip. So you can have conditional statements, for example, check if there's a noun preceding the word and only swap it in that case, or you can just have skips where it's going to be skipped in any case at all. So I'll show you again the raw data. Well, not again, but I'll show you the raw data here. It comes from 3 different sources, actually 2 sources, because only 2 of them are quite permissively licensed. So I have 2 different data sources here that end up getting pulled in to create my spelling crosswalk. And my spelling crosswalk here will list out all of these words in their UK variant and US variant. And it'll tell me about the sources here. And this is what's being used as a baseline for making all of the swaps. So about 6,000 words here. I have my list of exceptions that I have largely manually created here with the help of language models and just review of a lot of the data. And what this then allows me to do is to make these deterministic swaps here. So if you want, you can always transcribe and run this deterministic step yourself to get into British English or to get into US English consistently. There will be cases where it'll be hard to get the right swaps for reasons like I described, where you have words that have different spellings depending on context. That'll be harder to do unless you do an LLM pass. Of course, you could run your own manual LLM pass. Or if you want to transcribe in one shot using a model, then that's where these fine-tuned models come into play. And you can download and make use of these models or run your own server as well. So that's a quick overview of how to do transcription into different language variants. Let me know your comments or questions or interests if you wish to build on this or have me build on it. I'm considering whether I'll put out some models that do not just spelling, but also meaning. So they would convert from, say, trash to rubbish, or other words that are different into different languages, or potentially add on other variants, other English variants, or even other language support as well.